Very much. Where I am, it's morning, so good morning, good evening, wherever you are. I'm very happy to be in this event. My name is Antia Lamas Linares, and I'm the CTO of SpeQtral, which is a startup. And I'm going to talk today a little bit about our trajectory as a company, but also my own trajectory. I'll mix the two things a little bit. So first of all, a little bit of a clarification. I already messed up my own introduction by saying that I was the CTO of SpeQtral. In fact, what happens is that we have two companies. So SpeQtral is based in Singapore. Our company eventually comes from it's a spin-off from academia, from the group of Alex Ling at the National University of Singapore in the Center for Quantum Technologies there. And there I am actually the chief quantum scientist, whatever that is. But we also have a US company, and that is SpeQtral Quantum Technologies, and you can see the family resemblance there in our queue. And I am the CTO of our US company. The US company addresses mainly the US market, but also government sector kind of things, since it's very hard to do that kind of business when you're not a company based in a particular country. All right, and I'm based in Austin, Texas. All right, so what do we do at SpeQtral? So I thought I should clarify that just from the start, and it's very, very simple. This audience will understand immediately. We do entanglement in space, meaning that we build very compact and very robust, very bright entanglement sources, so entangled pair sources, and put them in really small packages that we can then put on satellites. And in fact, our most recent satellite is currently orbiting on a low Earth orbit, just, comes around every 90 minutes or so. And it's measuring Bell inequalities and doing all those fun things. So we have an entanglement source in space. Now, why do we have entanglement sources in space, and why do we care, and why have we formed a company around it? Well, again, this audience will understand. Quantum key distribution is an obvious first application of entanglement distribution, but also looking forward, obviously quantum networks. The moment you want to network your quantum devices, you need to distribute entanglement and do things like that. And also slightly more esoteric things like time transfer, and that is actually clock synchronization on a global scale. It turns out that you can use quantum technologies for that as well. We're very excited about that. So that's our company, that's what we do. And how did this happen, at least for me personally? How did I get there? Well, this is what essentially you would find in my LinkedIn page. I'm from Spain. I got an undergraduate degree in physics at the University of Santiago. Then I did a master's in applied optics at Imperial College London. I proceeded to do a DPhil in physics, that's a PhD everywhere else, at the University of Oxford, and then a postdoc at UCSB in California. Then I moved to junior faculty as an assistant professor at the National University of Singapore. And then we wrote a white paper and got a lot of money to set up the Center for Quantum Technologies in Singapore, and I became a principal investigator there. Then I moved to the US, and I actually moved to NIST Boulder to work in superconducting detectors. I stayed there for a couple of years, and then I moved to Texas, to Austin, and I became a research associate at the Texas Advanced Computing Center, which is, I think it's the largest non-government supercomputer in the world. It's a very large center. It's like the 5th largest in the world computer. And about a year and a half ago, I became the chief quantum scientist at SpeQtral. I joined SpeQtral. So that's the neat and tidy story. You can see I've been working in quantum technologies for around 20 years now. So I did my PhD already in making entanglement sources. So, I've been in this for a long time. But of course, that's not really how things work, right? That's not the reality. That's what it's in my LinkedIn profile. The reality is a lot messier. And I thought I would describe for this audience some of that actual path of how I ended up where I am. So I started the same way I started in the last slide. I got my undergraduate degree in physics, and then I tried to do a PhD at Imperial College, but they didn't want me for a PhD. It wasn't the right fit. So I did a master's in applied optics. And then I did my final project in Oxford, and they offered me to do a PhD there. The catch was that there was no lab. We were setting that up from scratch. It was just me and my supervisor. So I set up a lab. And then my supervisor, my PhD advisor, got hired at UCSB. So the whole group moved, and I set up a new lab. And then somehow he ran out of money. Things got a bit tight, so I had to leave a little bit in a hurry. And I got the opportunity to go to Singapore and set up a new quantum optics group. They didn't have any quantum optics. They wanted to get into quantum information, and I got that opportunity. So I set up a new lab. You're starting to see a thread here. Then we got that big grant, as I mentioned before, and we went to new facilities. So I set up a new lab. And then my partner, now husband, got a position in Austin, and we were doing the Singapore-Austin commute for a while. That wasn't working so well. So I got the opportunity to go to NIST Boulder, which was super exciting, and the Boulder-Austin commute is actually much better. So I spent a couple of wonderful years in Boulder at the group of Sewunam working on these superconducting detectors. But then, we had a family, and then I moved to Austin because we wanted to be all together. And there was a little bit of an interlude there, a couple of years. I was looking for a job, but it wasn't a very good time for that. I got really bored. I made a LinkedIn profile for my dog, and she got a lot more hits than I did. So that was a little discouraging. Anyway, I got an opportunity to join the Texas Advanced Computing Center at the High Performance Computing Group, and I decided to change fields. I went like, okay, this is something I like too, and I went for it. Or so I thought. So I joined TAC, and I started working in HPC. But that was just about the same time as quantum computing was really starting to get in the public consciousness. Google had made investments, Microsoft had made investments, and suddenly people in the HPC community were actually paying attention to that. And suddenly I was the closest thing they had to a quantum computing specialist. So I became the local quantum computing person. That was great. We did some things there. But eventually the opportunity to join SpeQtral arose, and that was just perfect because that is really my area of expertise: quantum optics, entanglement generation, and so on. So about 1.5 years ago, I joined SpeQtral, and you guessed it, I'm setting up a new lab here in Austin. And that picture there is just my excuse to show you a picture of my favorite experiment where we did entanglement distribution in the Grand Canyon. So anyway, why SpeQtral? What is special about our company, or why do we think it's the right moment to do what we're doing? Well, we are at a very interesting confluence of three trends. So one you're all aware of is the quantum technologies trend. This in the last 5 years or so, this really has taken off. People are super interested with the computing aspects, the networking aspects, the sensing aspects, and that's super exciting. On the other hand, we have an emerging trend on the space industry, and that is, they call it new space, in fact, and they contrast it to old space. So old space is the usual things you hear about, where NASA or somebody sends up a spacecraft, and by the time that spacecraft makes it into orbit or whatever, the technology is super outdated. It's 10 years old because it takes that long to space qualify and have redundancy for all the elements and so on. And it's incredibly expensive and very, very time consuming. And that is changing. Now, people are going towards a model where they launch small satellites, they launch them fast. Sometimes they fail. They're not as thoroughly tested as the old stuff, but it proceeds at a much faster pace. We also have another thing that is happening right now, which is optical communications in space. For a long time, this was conceived to be possible, but not really thought to be practical. And nowadays, it is. So there's an incredible industry development in optical communications in space, both in the old space industry and in the new space. So these things merge perfectly with what we are interested in SpeQtral, which is quantum communications and distributing entanglement and quantum states. So this is perfect, right? It looks like a great confluence, and that's what we thought. Now there's the reality, right? The reality is that you have to look for funding for these things. Now, if you think of, when people want to refer to the most esoteric scientists they can think of, they'll say, oh, it's a quantum physicist, or maybe they'll say it's rockets. This is rocket science. So we are right in the middle, or right at the intersection of those two things. And the thing with funding is that you don't just need money. You need a lead investor. You need an investor that takes ownership of the project. And then there are other investors that might join the round. And the problem is that doesn't intersect so well. So space investors are scared of quantum. If they don't know what that is, it's very different from what they're used to. On the other hand, you have quantum investors or quantum-focused investors, and they think space is hard and it takes forever and it's incredibly expensive. So a lot of them want to invest, but it's very hard to get somebody to lead. So that's not great. We encountered this in our seed round, which we got around a year and a half ago. And we're currently in the process of raising our Series A. And we keep running into this, which is that problem with finding leads in investment. So that is something definitely that I learned about. I didn't know this aspect of the startup ecosystem. So let me tell you something about our team. We're a small company. We're about 15 people, with about an even split between space-focused people and quantum-focused people. Obviously very academic heavy. We come from an academic group, but there's engineers, and there's quantum physicists, and there's space systems engineers, and all sorts of things like that. We also have a couple of people that have spent most of their career in industry, in the space industry specifically. So it's a pretty diverse team in many senses. So some final thoughts. Team building. This is something that is surprising. Succeeding in this quantum space is going to require really a special kind of team. You need quantum people to talk to space people. That is pretty hard, and it's a very hard team to assemble. So that is something it requires a special ability among the team members to communicate and be patient with each other. We're casting as wide a net as possible to capture this kind of talent. Hiring is very hard, and hiring outside the existing clubs is even harder, as you might all be aware of. So I'm going to put a little plug here that we are hiring. So, I have a wide audience here, and if you want to talk to me, just ping me in LinkedIn and so on. And thank you very much.